Okay. About what we have studied? About what we have studied? Rule number 20 in interface. Interfacing means what? The connection between the microprocessor and external devices like peripherals. Okay? Right? So
Yes,
this interfacing includes what? Both hardware and software, or only software, or only hardware?
software and hardware, ma'am.
Software and hardware. What do you mean by hardware? 21? 21.
Ma'am, external devices, ma'am. Hardware like keyboard, monitor.
Okay, those are the devices. Those devices we are connecting to the processor, right?
Yes,
That
ma'am.
is called as interfacing. Okay. So this
Okay.
interfacing can be done in both the ways,
Yes, ma'am.
hardware and software, right? So hardware means what? How we are interfacing?
By using drivers, ma'am.
By using drivers is software, not hardware.
Okay. Okay.
Hardware means by using the wires or cables, right?
Wires and
So
cables.
software means by writing the program. Okay. That is about the interfacing. Okay. So whenever we are interfacing some memory to the processor, right? Whenever we are interfacing some memory to the processor, question is for 22 Jansi.
Yes,
Okay.
ma'am.
What pins we should connect from processor to the memory?
Data, address line, data
Very good.
lines.
Address lines and data lines, two lines. Next, 25, 25, 25. Other pins, one is address line, second is data lines. Next, only these two pins we will connect, or any other pins are there? Huh? Are there any other pins are there? 25. Who is 25? 25. 25. Absent. 25 absent. 32. 32. 32. Unmute yourself. 32. I'm keeping absent. 32. 39. 39.
Yes, ma'am.
Chelma. What
Uh,
pins we should connect before going to interface any memory with the processor?
Address line, data line, control line, ma'am.
Address lines, data lines, control lines.
Control.
Control line includes
Read, write,
read,
input
write.
and input and output
Very
memory.
good. Read, write, and ALE
IO by
signals.
M.
Okay.
Yes,
IO
ma'am.
by M bar.
M bar.
Okay. These are the five control signals. Before going to interface any device with the processor, we need to connect compulsory. Okay. Now, next, what is demultiplexing? 44. Demultiplexing. What do you mean by
Ma'am,
demultiplexing? Hmm. చెప్పమ్మా. వాట్ యూ మీన్ బై డీమల్టీప్లెక్సింగ్? మీకు ఎంత అర్థమైతే అంత చెప్పండి, సో దట్ ఐ కెన్ అండర్స్టాండ్ మీకు ఏమన్నా అర్థమైందా కాలేదా అని. ఓకే. వాట్ యూ మీన్ బై డీమల్టీప్లెక్సింగ్?
is when both address and data lines will be active, madam. Logic.
వన్స్ అగైన్.
And 84 to 87 address and data lines will be active in
Separating
for
the
logic
address
1.
lines from the AD multiplexing lines, that is called as demultiplexing. Till this we have studied in yesterday's class, right? Interfacing means what? Once again I'll recall everything. Okay. Is my voice is audible? Is my
Yes,
voice
ma'am.
is audible? Okay. So interfacing
Yes,
means
ma'am.
about the connection between the processor and the other external devices. Okay. Processor means only CPU. Okay. Processor means only CPU. That includes only arithmetic logic unit, some registers, and some clock. Okay. So with this we cannot do until unless we connect the input output devices and memory. So how we are connecting these input output devices? Okay, through the cables or with the help of the hardware and as well as software. So the process of connecting input output devices and memory to the processor, microprocessor, is called as interfacing. Okay, so this is the simple block diagram of the interfacing. Okay, this is the simple block diagram of the interfacing. So now here what we are interfacing, first example memory we are taking. Okay, we need to interface memory and as well as the IO devices. But first we are taking an example as memory. Okay, we are interfacing the memory with the processor. So this is the block diagram. Okay, so here 8085 is our microprocessor, and next memory is the device which is to be interfaced with the 8085. So here between these two, what lines we are connecting? Address lines we are connecting. Okay, next data lines we are connecting. Next control lines. So address lines includes the what? A0 to A15 address lines. Why A0 to A15? Because 8086 is having 16 address lines. So how many address lines processor is having? Those many address lines we need to connect directly from 8085 to the memory. Okay, and next data lines. What we need to interfacing means the what? The transferring of data only, right? So in order to transferring of data, we need to connect the data lines directly from 8085 to memory. So how many data lines this 8085 is having? 8 data lines. So all these 8 data lines we need to interface from 8085 to memory. Okay. So D0 to D7 directly we are connecting. Next. Okay. We have connected address lines and data lines. So what we need to do with these address lines and data lines? We need to read the information or write the information, right? So read and write control lines also we should interface. See, read and write. And next, what which device we need to interface? Memory. So we need to connect IO by M bar control line also. This IO by M bar is used to select the which device is to be interfaced. If memory is to be interfaced means this IO by M bar line should be 0. Okay. If input output devices we need to interface means IO by M bar should be 1. Okay, this one. And next ALE. ALE is for what? To select the address lines. Okay, so ALE also we need to connect from 8085 to the other devices. Next ready. So ready indicates the what? Our processor is ready for interfacing. So this ready signal is also, ready pin is also we need to connect to the devices which is to be interfaced with the 8085. So these all are the pins, right? So this is the block diagram. Next. So here, so here A AD0 to AD7 pins are multiplexed. Multiplexed means what? For one pin, two operations are done. Okay. One pin. Here one pin is what? Any one pin. Suppose 20. Okay. Pin number 20 is what? AD0. So A stands for what? Address. That is the one separate pin. And D stands for what? Data. So that is also a separate. But these two pins are enabled for only one pin. And when this one pin will be enabled, whenever this AD is equal to 1, means for one only two operations should be done. So how two operations should be done means depending on the clock cycle. Okay. So for every instruction or for every pin, 8085 will allocate the certain time for the execution. Okay. That may be in milliseconds, microseconds, or some hundreds of microseconds or nanoseconds. So for every instruction, some time will be allocated, and this time will be equally divides. Okay, this time equally divides into a four parts, and they are T1, T2, T3, T4. So during T1 period, address will be allocated. Means whatever the data we want to transfer from one device to another device, the data should be stored in somewhere, that may be temporarily or permanently. Okay. Now in order to store the data, okay, we want some address, right? So that address is allocated during T1 period. Okay, T1 period, and remaining T2, T3, T4 periods, data will be operated. So like this, these multiplexed pins will be enabled or operated. Now here in interfacing, we should separate the A from D, A from AD lines. Okay, we cannot connect directly AD from processor to the interface. Is my screen is visible, all of you?
Yes, ma'am.
Hmm. Okay. So we cannot connect directly AD0 to AD0, AD1 to AD1, AD2 to AD2, like that we cannot connect. So what we need to do? We need to separate A from AD. Okay. So AD is called as what? Multiplexing. Okay. Now we need to separate. So now what word we need to use? Demultiplexing. Okay. Demultiplexing means what? The separating the address lines from AD multiplexing lines. Understand? Demultiplexing means what? Demultiplexing means what? Demultiplexing means what? Separating the address lines from AD multiplexing lines. Understand? 35? 35, are you there?
Yes, ma'am.
What is demultiplexing? This is important question in 1 to 10. Short answers. What do you mean by demultiplexing? Demultiplexing means what? 35. The 29.
Yes, ma'am.
What is demultiplexing?
Separating address and data lines from multiplex lines.
AD lines. Which
AD lines.
multiplexing lines? AD lines. Okay.
Yes, ma'am.
Demultiplexing means you remember A, separate A from AD. Okay. A from AD. So in order to separate AD lines, we are using, okay, we are using one device. Okay. So the device name is 74LS. Okay. 74LS373. Okay. 74LS373. Okay. This is also an IC. Whatever devices we are using in a processor, in a microprocessor, MPMC, all are the ICs only. Okay. So here also one IC we are using to separate. Okay. Forget about separate. We should use compulsory demultiplexing word. Okay. So in order to demultiplexing the AD lines, we are using one IC. So that IC name is 74LS373. Okay. What is that IC name? 74LS373 IC we are using to separate the address lines from the AD multiplexing lines. So this device is also called as latch. What we can call this device as? Latch. LATCH. Okay. This device is also called as latch. LATCH. Okay. So this is the diagram. With this diagram, we are separating the AD line. See, this is our 8085 microprocessor. Yes or no? This is our 8085 microprocessor, and this 8085 microprocessor directly A8 to A15 pins directly we are connecting to the memory, whatever may be the device. Okay, whatever may be the device. If the device we need to interface with the 8085 means A8 to A15 directly we need to connect. Okay, next AD0 to AD7 are the multiplexed lines, 8. So these 8 lines we are separating. See, we are separating A lines here, A0 to A7. How we are separating? All these AD lines are given to the 74LS373. And what we are getting as output? Okay, this is called as latch. LATCH, latch. Okay. So with the help of the latch, we are separating address lines. See, A0, A1, A2, A3, A4, A5, A6, A7 from the AD0 to AD7 lines. and these are the data lines. After removing the A lines, what will be left? Data lines. So data lines also connect directly to the interfacing device. So these all are the what? The pins which we should connect before going to interface any device with the 8085 microprocessor. And next, in order to enable these all these address lines, we should connect ALE pin also. Okay, ALE pin stands for what? Address latch enable. Okay, address latch enable means what? Address will be enabled. So which addresses? The addresses which are given to the latch. Okay, what addresses we are giving? AD0 to AD7. So in order to enable these or in order to enable the latch, we should use ALE pin. Okay, so this is the circuit diagram. But this is the circuit diagram of demultiplexing A lines from AD lines. Okay, take screenshot. Okay, this is very, very important. Understand? What is this circuit? What is this circuit? What is the name of the circuit? Demultiplexing A lines from AD lines. Okay, next. Okay, so this is the demultiplexing normal block diagram. That is a circuit, and this is the block diagram. See 8085 memory chip, and this memory chip we want to interface with the 8085. So we have connected. And what lines we have connected? First, address lines A8 to A15 we have connected. Okay. Next, control lines we have connected. Control lines includes what? Read, write, ALE, M by IO bar, and ready. Okay. All those lines we are connecting directly from 8085 to memory. Okay. And next, AD are the what? Multiplexed lines. So what we are doing? We are connecting one latch. Okay. So for latch, we are giving the input as AD0 to AD7. Okay. And output of the AD latch is what? A0 to A7. These are given to the memory. Okay. And after separating A0 to A7, what are left? D0 to D7. So D0 to D7 also we have connected directly to the memory chip. Okay. Take screenshot of this one also. This is a block diagram of demultiplexing address and data lines. Okay. This is the circuit diagram. Okay. Here clearly we have mentioned one by one. Here one line stands for some lines. Okay. Understand demultiplexing? Understand? Give some
Yes, ma'am.
response. Okay.
Yes.
Next. How we will generate the control signals. Okay. I said how many control signals we are using? Read, write, M by IO. Okay. Next, ALE, ready. Okay. So among this, ALE is to enable the latch or enable the address lines. Ready is for used for ready the giving the ready signal of the processor. Okay. Now ALE ready is removed and IO by M bar is used to select the chip. Okay. If we are interfacing memory means IO by M bar is equal to 0. Then we can interface memory to the 8085. If this is equal to 1 means we can interface input output devices. Maybe both input or output or anyone. Okay. But in order to interface the memory, this pin should be 0. Why 0? Because above bar is there. Okay. Now this pin is equal to 1. Then input output will be interfaced with the 8085. Okay. Okay. So ALE is over from the control signals. ALE is over. IO by M bar is over. Okay. Next, ready is also over. What are left? How many signals are left till now? RD. RD stands for read. Next, WR. Write. Okay. Read, write. Now, which operation should be done at what time? How we can say? Based on these signals. Okay. So, in order to select the, see, read means memory read will be there, IO read will be there. Read means what? Read means what?
Taking
Very good. Taking data from other devices, right? Processor is taking, processor is fetching data. Means what? Read operation. Okay. If processor is writing, processor is writing the results on the output. Then that is called as what? Processor is giving. Writing means the what? Giving. Processor is storing some information in the memory. So that activation, that is called as what? Writing. That operation is called as what? Writing. So when processor will write the operation, when processor will read the operation, how we can know? Based on the control signals. Okay. Based on the one truth table. Okay. So this is the generation of the control signals. This is a circuit for generating the control signals. Okay. How many control signals we are having? Memory read, IO read. Okay. Means what? Memory read, IO read means what? Processor can fetch the data from memory and as well as from the input output devices. Second, memory write and IO write. Memory write and IO write. Memory write, IO write means the what? Processor can load the information into the IO devices or memory. Loading means the what? Storing. Okay, right? So these four operations will be done. How these four operations will be done? Based on this truth table. Okay, first memory read, memory write should be done. Okay, memory read operation and memory write operation should be done. In order to do memory read and memory write operation, first this IO by M bar should be 0 0. Why 0 0? Because IO by M bar. Okay, in order to select the memory operation, that may be read or that may be write. Okay, that may be read or that may be write operation. Hmm? That is a memory means IO by M bar should be 0. So that's why here 0 0 we have mentioned. Now among this zero memory operation is done. Now in this memory operation, particularly read operation is going to do or write operation. How we can say? Read means read should be 0. Both are bar only. Read bar and write bar means both these operations will be enabled for 0 only. So whenever RD bar is equal to 0 means I by M bar 0, RD bar 0. 0 0 means memory read operations will be done. See here. IO by M bar 0 and read is equal to 0. 0 0. Okay. Then what operation should be done? Memory read operation should be done. Okay. Memory read operation should be done. Next. Memory write operation. For memory write operation, IO by M bar should be 0 and write bar also 0. Okay. So again both 0. IO M is equal to 0 and WR is equal to 0. Then memory write operation. Now IO read, IO write is what? 1, 0. Okay. In order to select the IO operations, IY M bar is equal to 1. Why 1? Because above IO there is no bar. Here bar will be there. Here also bar will be there. Okay. So 1 1 means IO operation will be done. Now here in the IO operation, particularly read operation or write operation, how we can say? By making 0. Okay. If read bar is equal to 0 means and IO by M bar is equal to 1 means IO read operation. Okay. Now WR bar is equal to 0 means IO write operation. See 1 0 IO read. 10 I override. Why we have connected this not? Because the signal is always 0. Now, in order to perform the IO operations, we need to make this 0 is as 1. So how we can make 0 as 1? Not. Not. What is the input? Output will be the opposite to that. So input for this not is equal to 0, not get. And output is equal to 1. So 1. That's why here we have connected what? Not gate. Okay. This is the generating control signals. Understand? So this circuit also we need to draw in the interface. I am explaining part by part. Okay. After end of this session, we can say that we will join all these diagrams to make or to get a interfacing circuit. Okay. Understand? This is the simple block diagram. Actual, this is the simple block diagram. In this way, we need to connect. Okay. So this is the generating control signals. Any doubts? Any doubts in generating control signals? Any doubts?
No, ma'am.
Very good. So that I can move next slide. Next. So here we need to interface memory and IO devices. I said. Okay. First we will study about the memory interface. What interface? What interface?
Memory interface.
Memory interface. So here this memory is divides into a two types. Okay. In microprocessor, memory is divides into a two types: primary memory, secondary memory. As you know, all of you. Okay. Primary memory, secondary memory. Primary memory means what? It is also called as main memory. Means the memory which is includes in the processor is called as primary memory. Okay. Memory means the what? The memory which includes in the processor, like RAM, ROM. Okay. RAM, ROM are called as the primary memory. We cannot separate these two. Okay. RAM means what? Random access memory. Okay. So here we can store the data temporarily. After switching off the system or the processor, the data which is stored in the RAM is erased. Okay. And ROM or OM ROM, read only memory. This is used for storage of the operating system. Okay. This is used for the what? Storage of the operating system. Like what operating systems we are using nowadays? Hmm? In the laptop systems, what operating systems? Or in mobiles? In mobiles, Android. Okay. In laptops or systems, Windows 10. Okay. Windows 10, Windows 8, Windows 7, Windows XP, Windows, Linux. All these are the what? Operating systems. So this system, without this operating system, we cannot use the processor. Okay. So these operating systems are stored in the ROM or OM permanently. We cannot erase. But whereas RAM, we can store the data temporarily. Here also all the executable files only we can store. But these these files will be stored temporarily. Okay. If we switched off the system or if power is gone suddenly, the data, everything will be stored here, will be erased. Okay. Those are examples of primary memory, RAM and ROM. Okay. Now, based on the RAM, the speed of the system will be decided. Okay. Based on the RAM, the speed of the system will be decided. Okay. Next, secondary memory. Secondary memory means what? To store the data permanently. Okay. To store the data permanently. Example, CD drives, hard disk. Okay. Magnetic tape. This was we are using earlier. Okay. Before CDs. Okay. Next, pen drives, DVDs. All these are the examples of the secondary memory. Okay. All these are the examples of the secondary memory. So memory is classified as how many types? Mainly two types, primary and secondary. Under primary, what are the examples? RAM, ROM. Under secondary, hard disk, CD drive, DVD drive, magnetic tape, pen drives, all are the examples of secondary memory, and these are non-volatile. Non-volatile means what? Huh? If you switch off suddenly or shut down suddenly, power is gone suddenly, whatever it may be, the data once we have stored in this, we cannot erase automatically. Data cannot be erased automatically until unless you'll do manually. Understand? Right? So this is called as what? Secondary memory. So now we need to interface primary memory and also secondary memory. Okay? And next, this is the circuit diagram of memory chip. Okay? That may be a primary or secondary, whatever it may be. In the circuit diagram, we need to draw the circuit of interfacing, right? So in the circuit diagram, the memory should be represented by like this. Okay? The memory should be represented by like this. This is the memory chip diagram. Okay? So memory. So memory capacity will be decided based on the its data. Okay? How much data for this memory? It stores the all the 8-bit data. So 8 into for 8, how many bits at a time it will store? How many address lines? This one is having 16. So 8 into 2 power 16. Like that we will say the disk or chip capacity. Okay? So I'll tell later. Okay? So this is the what? Chip, memory chip. Memory chip capacity or size will be decided by 2n into k. K is equal to bits per word. How many bits per word? One word is equal to how many bits? Hmm? One word is equal to how many bits? Hmm? 16 bits. 2 bytes. ఇప్పుడు ఇక్కడ ఇవి చాలా ఇంపార్టెంట్ అమ్మా. Okay, now. So this chip is having how many pins? Okay, first we need to like this so many chips we can interface. Okay, this is the example of the one chip. Understand? One memory device. So like this memories we can interface more than 7, more than 8, more than 2. Okay, so as many as possible memory chips we can interface. So now here this is the only one memory chip we are having. Okay, so like this memory chips we are having 2. Okay, and these 2 or 3, these 3 are interfaced with the processor. Okay, these 3 are interfaced with the what? Processor. Okay, now first we need to select this chip or else this chip or else this chip. Which chip we need to select? That will be based on this chip select signal. Okay, in order to select the particular memory or particular memory, we should give the signals to this chip select. Then only this chip will be enabled or selected for the interfacing. Understand? So chip select is used for what? For selection of the memory. So this is the first chip. And now memory. We are interfacing what? Memory to the processor here. This is the example of the memory chip. So what pins directly we should connect? All the address lines we should connect. So n address lines. N indicates the what? 8085 we are connecting. So all 16. N is equal to 16. So 16 address lines are we are connecting directly to the memory chip. Okay. And next 8 data lines. K data lines. Okay. These are the input. Okay. Some information we are giving and some information we take. So 8 data lines we are connecting and 8 data lines we will take. Okay. 8 data lines bi-directional. Always data lines if you connect means draw bi-directional. Okay. Inside arrow indicates the input. Outside arrow indicates the output. Okay. So first what signal we need to connect? In order to select that chip select signal we need to connect. So this is the one signal. Second, all address lines we should connect. Address lines are unidirectional only. Okay, this is second. And next, third, data lines. Data input lines, data output lines. Next, control lines. 4, 5. Okay, this is memory. So memory by IO bar directly connected. Okay, IO by memory bar. Okay, clear ma? This is the memory chip circuit. Understand?
Yes, ma'am.
Okay. Draw this. This is also very, very important in 1 to 10 questions. Draw the memory chip circuit diagram and what pins it includes. Okay. Next. This is the complete interfacing of block diagram. ఓకే దీంట్లో సింపుల్గా ఇచ్చేసినాం ఈ ఒక్క లైన్ ఈజ్ ఈక్వల్ టు 8 లైన్స్ 60 లైన్స్ అట్లా నెక్స్ట్ బిగ్ దాంట్లో డ్రా చేస్తాం అన్నట్టు ఓకే సో నౌ టెల్ మీ హియర్ వాట్ వీఆర్ ఇంటర్ఫేసింగ్ మెమరీ టు ద 8085 ఓకే రూల్ నెంబర్ 10 came or else rule number 90 rule number 10 can you explain this circuit diagram here we are interfacing memory to the 8085 processor can you explain this 19
Yes, ma'am.
can you explain the circuit what we are doing here everything is in front of you just I want in sentence form what we are doing with this
We are interfacing memory, ma'am, with processor.
Very good continue so in order to interface the memory with the processor what we need to do one by one you say step by step first we are connecting this
Address
blue line 1 point
Next, we are connecting address latch. We are enabling address latch enablement.
very good ALE we are connecting ALE comes under control signals to enable the latch so what is the use of this latch latch is used for what latch is used for what see
For separating A from AD lines.
very good for separating A from AD lines so AD lines we have separated A from AD lines so these lines we have connected directly and next what are the remaining after separating A0 to A7 D0 to D7 are left right
Yes, ma'am.
so these D0 to D7 also we have connected directly why two arrows for all these we have given only one arrow see unidirectional why data lines are bidirectional tell me why this green line is having two arrows we are saying we are giving address but not data giving data transferring okay we can transfer data from processor to memory and memory to processor so that's why data lines are what bidirectional next see IO by M bar IO by M bar is connected to the chip select chip select means the what this is used to select the memory now IO by M bar should be what 0 or 1 in order to select this memory this IO by M bar should be what
Logic 0.
logic 0 next RD is connected to RD okay right bar is also there right also we need to connect from here to here so this is the what complete interfacing of the memory to the 8085 microprocessor this is called this part of circuit is called as interfacing circuit okay next now here only one memory chip is there okay like this two memory chips we are having means here we are connecting interfacing only one memory chip okay we are interfacing only one memory chip now like this memory chips we can interface more than two more than one so now here I have taken example of two this is one and this is second so how we can connect all these signals we need to connect again here like this Understand? Are you following? Okay, like this,
Yes.
like this we need to connect. Okay, if one more chip is there, then again like this. Okay, we need to draw neatly. Every line should be represented neatly. Everything, see. Like this, we need to interface. This is the procedure to draw the interfacing circuit. Understand? One means only one line. Two, three chips means like this, from this. Okay, like this. From green to 3, blue to 3, this blue to 3, red to 3, this red to 3. Okay, now see here, this is the one memory and this is the second memory. Now how we can select this memory? Based on the two address lines. If only one memory is there means only one address line is selected, means we are having 16 address lines, right? So among these 16 address lines, okay, only one memory means one address line is selected to select the chip, to select that memory. If two are there means how we can say two address lines will be allocated to select the chip. Okay, so how we are selecting? First 0, A0 is 0, A1 is 1, means one chip will be, one memory will be selected. Now A1 is 0 and A0 is 1, then another memory will be selected. Like this, by using two address lines we can select four memory chips, means we can interface four memory chips to the processor. 0 0 means one memory chip will be selected. Okay, 0 1 means another memory chip, memory 2. 1 0 means memory chip 3 will be selected. 1 1 means memory chip 4 will be selected based on the truth table. If more than 4 we are having, then A3 we should use. A0, A1, one more A2. Now 0 0 0 means one memory chip will be selected. Chip 1. 0 0 1 means second chip. 0 1 0 means third. 0 1 1 means fourth. 1 0 0 means 5. 1 0 1 means another. 1 1 0 means another. Triple one means lost. Understand? Like this, memory chips will be selected. Understand? Here three are there. One is there means only one address line is enough. But three are there means which chip we need to select for interfacing first, or in which chip we need to store the data first. How we can select? I want to select this. This is one. Second, second. This is three. Three memory chips we are interfaced with the processor, right? Okay. Now I want to store the data from the processor to the second memory chip. How we can select this second memory chip? Means based on the address lines. Two address lines are allocated to select the chip. If two address lines are 0 0 means this chip will be selected. 0 1 means this one will be selected. 1 1 means the third chip will be selected. Now I want to store the data here means A1, A2 should be 0 and 1. Understand? Like this. This is the two. Okay. This is the interfacing of memory chips. See. Okay. Understand? Now, see. If only memory chips, memory 1 and 2 means with the help of the NOT gate, we can select. Okay. But if memory chips are more than 2 means we cannot use NOT gate. Okay. Then at that time we need to go for the decoder. Okay. We need to go for the decoder. This is the decoder circuit. Okay. For this decoder, input should be 3. 1, 2, 3. Means input should be always address lines. Okay. Address lines. Among 16 address lines, we can choose any 3 address lines for the selection of the decoder. Okay. Here I have taken as example as A11, 13, 12. Okay. According to the problem, we can get anything. Okay. So 3 address lines are given. So this is the decoder. 2 power 3. How many inputs, how many outputs we will get? 8. Okay. Here I have taken example as 4 memory chips only. Okay. but up to 8 memory chips we can connect. Okay, this is called as decoder to select the memory chips. This is the complete circuit interfacing circuit diagram including decoder. Okay, this is 8085. Okay, so here one memory chip we are connecting. ఇంకొకటి ఎగ్జాంపుల్ కూడా చెప్తామా 3-4 మెమరీ చిప్స్ ఉంటే ఇంకా కొద్దిగా డయాగ్రామ్ పెద్దగా అయిపోతుంది. ఓకే, this is the here one memory chip we are connecting. That's why we are using AND gate. Okay, so if more than 2 memory chips means we go for the, in place of this we will draw the decoder, this decoder. Okay, right, see address line, same address lines are connected. Okay, first address lines are connected directly here. Next AD lines are connected. Next data lines are connected. Latch is used to separate the A from AD. NAND gate, memory read, memory write. See, memory read, memory write. Why? Because we are interfacing memory. Okay, clear? Clear or any doubts? Next, decoding means what? Connecting more than 2 memory chips to the processor. Okay, now this address decoding is done in 2 ways: exhaustive or linear decoding, partial decoding. Okay, this first exhaustive decoding means what? Complete address lines we are utilizing. Okay, if we are utilizing complete address lines means what? The hardware required is more. Okay, if everything we are connecting means what? The speed of the processor will be reduced. Whereas partial decoding means what? This is very simple. Okay, how many address lines are required to connect? 4 address lines among 16. So 4 only we will connect. Okay, or 10 address lines are required to connect, then 10 only we will connect. So based on this, what will happen? The hardware required to be connected is less. If hardware is less means the construction will be simple and cost will be reduced, speed will be increased. Okay, understand? Interfacing IO devices I'll tell later. Till this understand?
Yes, ma'am.
Any doubts? In next class we'll discuss about the IO interfacing, and before that we'll do one problem based on the memory. Okay, any doubts? Any doubts?
No, ma'am.
Only one.
No, ma'am.
Very good.
ma'am.
ఇంతమంత మెల్లగా గట్టిగా చెప్పండి. ఒకసారి రీకాల్ చేసుకోండి వాట్ వీ హ్యావ్ స్టడీడ్. Till that I'll take the attendance. Give your attendance. 14 series 46 absent. Akila 17 series 53. Next rule number 1.
Yes, ma'am.
2,
Yes, ma'am.
3,
Yes, ma'am.
4. 4. Don't type in the chat box. 4.
Yes, ma'am. Present, ma'am. Present, ma'am. 4.
5,
Present, ma'am.
6. Absent 7. 7. 7. Radula. 8.
Present, ma'am.
9.
Present, ma'am.
10.
Present, ma'am.
11. Why 11 is absent? 12. Absent. 13. 13. Avinash. Absent. 14.
Present, ma'am.
14 present. 15.
Present, ma'am.
16.
Present, ma'am.
17. Absent. 18. 18. 19.
Present, ma'am.
20. 21.
Present, ma'am.
21.
21 present, ma'am.
22.
Present, ma'am.
23. 24. 24. Srinidhi. 25. Pravalika. 26. Kyati.
Present, ma'am.
ఎందుకమ్మా మీరేం ఆన్సర్ చేయరు ఖ్యాతి?
ఏం లేదు మ్యామ్ అట్లా.
27 చేయాలి. మీరు చెప్తే మీరు ఉన్నట్టు తెలుస్తుంది క్లాస్ లో. 27.
ఓకే మ్యామ్.
28. నిహారిక. 29.
ప్రెసెంట్ మ్యామ్.
Present, ma'am.
28 came. 28. 29.
Yes,
Present, ma'am.
30. 30. 31.
Present, ma'am.
32. Say like this, ma. 32 present, ma'am, like that. 32. Absent. 33. 34. 35.
Present, ma'am.
36. 36 సిద్ధార్థ్. సిద్ధార్థ్ నీ ఐడి కార్డ్ వచ్చిందమ్మా. 37. Absent Arun. 38. Maharshi. Absent. 39. Chandana.
Present, ma'am.
Okay. 40.
Present, ma'am.
41.
Present, ma'am.
42. 42 జార్జ్ నీది కూడా వచ్చినట్టుంది ఐడి కార్డ్. 43. 43. Absent. 44.
Present, ma'am.
45. 45.
Present, ma'am.
44
ma'am.
came. 44. 46.
44 present, ma'am.
Okay. 46. 46. 47. 40.
Present, ma'am.
48.
Present, ma'am.
49.
49 present, ma'am.
50. 51.
Present, ma'am.
52. 52. 53. మీకు ఏ నెంబర్ పిలుస్తున్నానో తెలుసు
Present, ma'am.
కదమ్మా, కొద్దిగా ఫాస్ట్గా చెప్పండి. 53.
Present, ma'am.
54.
Present, ma'am.
50. 301. Earliest who are absent, who are present, tell me.
310 present, ma'am.
Present,
3.
ma'am.
301.
307, ma'am.
307. 3. Before 307 all are absent.
310 present, ma'am. 310.
Okay. 307, 310 present. Remaining all are absent. Right?
Yeah, ma'am.
Okay, ma'am. Is your next class?
Thank you, ma'am.
Okay, ma'am.
Hello.
Good morning.
Good morning, sir.